Okay, this video is going to cover the last two optimization questions, questions 4 and 5. So we're back to Scuba Steve, and he is enclosing an area of his harbor for 2 sharks that he wants to keep as pets. He has 450 feet of fencing for the sides of the 2 cages. He needs to separate the 2 so they won't kill each other, but they need to have the same size cages. What is the maximum area of each section of the cage that he can build? Alright, so first of all, we're going to start off with what we want to do. We want to maximize area, so we need to come up with an equation for the area of these cages. So they tell us that the width is x and the length of one cage is y. These are the same area, so this is also y and here's x. So the area of just one section, because it wants to maximize the area of each section, they're both the same. So the area is x times y. So we want to maximize that area. Alright, so again, we need to get this in terms of just x or just y. So they tell us that the fencing is 450 feet. So if you look at this, we have the 2 cages, but then they share this x length here. So if you look at how it's drawn out, we have 4 y's and 3 x's, and that equals 450 feet. So using this equation, we're going to solve for either x or y. Now 450 does not divide evenly by 4, it does divide evenly by 3, so I'm going to solve for x here. So that would be 450 minus 4y divided by 3, or 150 minus 4/3 y. So then we're going to take that and substitute into our formula for area. Giving us 150, not 105. Okay, so there's our area formula in terms of y only. So now we want to take the derivative of this with respect to y and find where we have a maximum. So go ahead and do that. Alright, when you take the derivative and set equal to 0, this is pretty straightforward. You should get that y is equal to 56.25. Now, in the first optimization, when we looked at the calculator and we talked about the decimal places, here, when you found this, it actually was a round 0.25. It wasn't 0.25, 03, and so forth. So if it actually does come out to a clean 0.25 or 0.75 or 0.5, it is actually okay to leave it as 0.25. But when in doubt, if you want to make sure that it's 3 decimal places and you don't leave off anything, if you do put a 0 here, it's not incorrect. So either way is really fine for this problem. Okay, so the question actually asks what is the maximum area of each section. I forgot to check to make sure that this was in fact the maximum. So again, if you check using your calculator if you need to, you will get a positive at 56 and a negative at 57, so this is maximizing area. So the maximum area would be x times y. So we have our y, but we also need to find our x. Or, actually, we don't even have to do that because we have an area in terms of y only. So if you use your calculator and you do the such that, like I taught in the first video, then you can find that x, or no, not x, sorry, to find the area, 18.75 feet squared. Okay, so again, for sake of time, I'm not writing it out, but your final conclusion statement would then be that Scuba Steve would have to build a section of the cage with an area of 4,218.75 feet squared in order to maximize the area of each section. Something to that effect. Alright, so the very last video that we're, or not video, the lesson example that we're going to do is example 5. Back to Emmanuel the duck. I wish that would go away. Okay, so Emmanuel the duck is standing at the edge of a slow-moving river, which is 1 mile wide. He knows that it is dinner time because he smells the yummy fish burgers on the grill at his campsite across the river. He can swim at 3 miles per hour and waddle at 2 miles per hour, which makes sense, but actually for this problem, I'm going to change this. I'm going to change it to swim at 2 miles per hour and waddle at 3 miles per hour. I switched it up and then realized the problem didn't work with that, so we'll put it back to that. So he must first swim across the river to any point on the opposite bank. From there, he can waddle to the campground, which is 2 miles from the point directly across the river from where he starts his swim. What route will take the least amount of time, and how long will it take Emmanuel to get to dinner? So he's standing at the edge of a river, which is 1 mile wide, and then his campsite is across the river. So I'm going to draw just a very basic. There's a river. All right, if you want to show water, okay. He's standing over here. I know this is not a duck, but whatever. He's standing on one side of the river. The campsite is down the river and across the river. So let's say that that is his yummy hamburgers cooking on the grill. All right, so he wants to swim across the river. And so he's going to swim across the river at some point, and then he's going to walk the rest of the way. All right, so we want to know what each of these distances are going to be so that we can minimize his time, so he can get there the fastest. All right, so you'd be tempted at first to call one of those lengths x and one of those lengths y. But remember, we want to make sure that our formula is going to be in terms of one variable only. So if we want to find the least amount of time, and we're talking about distances and rates, if we remember that distance equals rate times time, then his time is his distance divided by his rate. So the distance, so our final time will be the distance he swims over the rate he swims plus the distance he walks divided by the rate that he walks. So we want to get all of that in terms of one single variable. And so the best way to do that is if we talk about, let's look at some of the things in the problem that I didn't put in here. The distance from him to his campsite is 2 miles. All right, and then the length of the river is 1 mile. Okay, and if you can kind of see the shape that we've got going on here, we've got this right triangle happening here. Okay, so this is going to kind of seem counterintuitive at first, but I'll show you how it all works out. We want both of these lengths to be in terms of the same variable. So what I'm going to do is I'm going to actually call this variable, this length right here, x, which is the horizontal distance that he swims, not the actual length that he swims. So if I call that horizontal distance x, then the distance that he walks is going to be 2 minus x. This vertical distance that he swims is 1 mile, so then with the right triangle, we can figure out the actual distance that he swims using the Pythagorean theorem. So that's going to be the square root of x squared plus 1. So now we have the distance that he swims and the distance that he walks in terms of one single variable. All right, so now let's take the formula that I wrote and rewrite it all in terms of x. So his total time, the distance he swims is the square root of x squared plus 1 divided by the rate that he swims, which we switched to 2 miles per hour, plus the distance he walks, 2 minus x, divided by the rate, which was 3. So this is our equation for the time that it will take him to cross the river. So now what I want you to do is derive this, set it equal to 0, and solve. Okay, this is a lot to look at, so I'm just going to kind of go through it piece by piece. So when I take the derivative of t, you have to use the chain rule here. So this first thing has okay, sorry about that. I was looking for a pointer so I can point at this. But the first expression, you're going to have to use the chain rule. So you have the 1/2 as the constant multiple, and then you have the square root of x squared plus 1, so the derivative of that would be the 1/2 times x squared plus 1 to the negative 1/2. Then use chain rule times 2x. And then the same with the next expression. So then I simplify that, set it equal to 0, and then solve. So just take a look at what I have here and copy that down. Okay, so hopefully you are getting what I got. You followed my work. So I got that x equals 0.894. So that is, the time is minimized at 0.894. We want to double check using our calculator. It is in fact a minimum. So the question is asking what route will take the least amount of time. So we found the x, which actually is neither route. We want to look at the swim and we want to look at the walk. So what I would say in order to answer this question is find the distance that he swam, plugging in for x, and then find the distance that he walked, and then put it all together into a sentence. So let's do that now. Go ahead and find both of those distances. Okay, so I calculated the distance it would take him to swim and the distance to waddle. So my final statement would be that Emmanuel needs to swim 1.491 miles to a point 1.106 miles from camp. The final thing that we need to do is figure out how long it would take him to do that. So we go back to our formula for time, which was here, and plug in x for that and figure out the time. So if you were to do that, you would say this takes him 1.044 hours. Okay, so that's optimization. I hope everything makes sense. And I'll answer any questions next time.